Hello everyone, all my dear students. Today we are going to see one more arithmetic application, and that application is 4-bit binary adder. It is 4-bit binary adder. The 4-bit binary adder adds the two binary numbers. It adds the two binary numbers, but these two binary numbers are the 4-bit binary number. It means here the logical circuit which adds the two binary numbers having 4-bit, that logical circuit is we call as a binary adder. And here today we have to see how the binary adder works, what type of the logical diagram or the block diagram we use for the binary adder. For example, if we have the two binary numbers, and these two binary numbers are A3, A2, A1 and A0. This is the first binary number. Here these binary number having the 4 binary bits, and these 4 binary bits are A3, A2, A1 and A0. We also have the second binary number, and that second binary number is B3, then B2, B1 and B0. This is the second binary number. Again, this number is the 4-bit binary number. If we have to perform the addition of these two numbers, first number it is we call number A, and second number is we call the number B. If we have to perform the addition of these two numbers, then it can be performed by using the 4-bit binary adder. Okay, so suppose we have these two numbers, then it is performed by using the 4-bit binary adder. But instead of these 4-bit, if we have the many bits, the number having the many number of bits, then that adder is we call as a binary adder. That adder is we call binary adder. So we can say the binary adder is a logical circuit which performs the addition of two binary numbers. A logical circuit which performs the addition of the two binary number, whatever the number of binary bits, then it is we call as binary adder. This is we call binary adder, and this binary adder may be a 4-bit binary adder, or it may be 8-bit binary adder, or it may be 16-bit binary adder. Okay, so the logical circuit which performs the addition of the two binary numbers, whatever the number of binary bits, then it is we call as a binary adder. Here we have to use the 4-bit binary adder, and that 4-bit binary adder can perform the addition of the two 4-bit binary numbers, the two binary numbers, but both the numbers having the 4 bits. Okay, so that's why this adder is we call as a 4-bit binary adder. Okay, now how the addition can be done? The addition can be done by using a previous two circuits which we had seen in the last video lectures. If you not seen that video lectures, then I will provide its link in the iCard here, or I will put the link in the description box. Okay, so here the two adders we have seen, the first adder we seen, that is we call half adder. That is we call half adder, and this half adder performs the addition of two binary bits, not two binary numbers. It performs the addition of the two binary bits, but it is a half adder. There is no provision of adding the carry generated or the third bit. That's why it is we call as a half adder. One more adder we had seen. That adder is we call as a full adder. That adder is we call a full adder, and this full adder performs the addition of three binary bits. It performs the addition of three binary bits. So these two circuits we can use for the construction of the 4-bit binary adder, or we can say for the construction of a binary adder. Okay, but how we can connect it? For that, here we have to make the addition of these two numbers, then it gets very clear for you how we can make the construction of the binary adder. Okay, so here we make the addition column by column. First, I will erase it, and again I will write down all these two numbers. The first number we have, that first number is the A number having the 4 binary bits, and these binary bits are A3, then A2, then A1, and the last bit is the A0. Okay, from this 4 bit, here this one bit which is at the right hand side, this bit is we call as LSB. This bit is we call LSB, and this one bit is we call as MSB. I think the LSB and the MSB we had seen in our number system lectures. Okay, so here the first number we have, that first number is the A number, and the second number is the B number having once again the same binary bits. These are the 4 binary bits. Okay, so the MS bit is the B3. The next bit to the MS bit is the B2, and then B1, and LS bit is the B0. Okay, we have to perform the addition of these two numbers. First, while doing the addition, what we do here, we perform the addition of these two numbers, these two bits, and the bits are the LS bit of both the numbers. We perform the addition of these two LSB bits. Okay, and here the result is what? Result is the sum and the carry. We write down here the sum as 0, and if the carry is generated, then that carry is supposed to be C1, and this carry we add to the next column. So here for the addition of these two binary bits A0 and B0, only two binary bits are there. So therefore here for the construction of this we can use one logical circuit. That logical circuit is we call as half adder. That logical circuit is we call half adder. Means here for the addition of these two bits we use the half adder circuit. Now after addition, here we get, if we use the half adder, then here it performs the addition of A0 and B0. It produces the output as sum and the carry. The sum we write down at the result, and we add the carry to the next column along with its actual binary bits. Okay, in next column we have the binary bits. These binary bits are A1 and B1, but we have to add the carry generated from the previous column. So therefore here there are 3 binary bits. How many bits are there? 3 binary bits. And for the addition of these 3 binary bits, what we use? We use the full adder circuit. The half adder is a logical circuit which performs the addition of two binary bits, and a full adder is a logical circuit which performs the addition of three binary bits. So for this column we require to use the three binary bits adder, and that circuit is we call as a full adder. Means here for this column we require to use the full adder. A full adder is a logical circuit which performs the addition of three binary bits and produces the output in the form of sum and carry. Here again we get the sum. We nominate that sum as sum S1. Okay. Now the carry, if generated, then that carry either it is equals to 0 or 1. That carry we add to the next column. So here we get the carry is equals to C2, and this carry is added to the next column along with its actual bit. So here in this column once again we got the three binary bits, and these binary bits are C2, A2 and the B2. Again here we require to use one full adder, and this full adder performs the addition of the three binary bits A2, B2 and C2 and produces the output. That output is supposed to be S2, and the carry generated, that carry is the C3 we add to the next column. Okay. Now at the next column we have again three binary bits, and these three binary bits are added by using the full adder. Means here once again we require to use the full adder. Okay. We require to use the full adder. This full adder performs the addition of three binary bits A3, then B3 and this C3, which is the carry generated at the previous column. So here we get the output, and that output is the sum S3, and here the carry generated, that carry we write down directly. Means here there is no previous column for the addition. That's why here we require to write down it. We require to take it at the outside. So here this is the carry C4. Okay. So here this is the arrangement which we have to made for the construction of the binary adder which performs the addition of four binary bits. Okay. So here we have to see how we can perform the addition. But before that, here one thing we have to note down. Here the three full adders we use, three numbers of the full adder we use, and one half adder we are using. We are using three number of the full adder and one half adder. Here what if instead of this half adder we use the full adder? Means here to make a common hardware we can use the four number of the full adder, so the hardware gets common. But we have to make one arrangement. What is that? In that arrangement, here the full adder which is having the three input terminals, as it performs the addition of the three binary bits. So if we have to use the full adder instead of this half adder, what we do? We add the third binary bit. Suppose here the third binary bit is C0, then we have to make this C0 is equals to 0. So there is no effect of this C0 in the addition of the two binary bits A0 and the B0. Okay. So here we can construct this binary adder, the 4-bit binary adder, by using either three number of the full adder, one half adder, or we can construct it by using only the full adder, but we required one full adder for the one column addition, means we require to use the four number of the full adders. Okay, so what type of logical circuit we require to use and how we construct it, we have to see by using the block diagram, or we can say it is also a logical diagram, because one block here acts as a one logic circuit. Okay, so here we have this logical circuit. This logical circuit having the three number of full adder. Here in this logic diagram, this is the full adder. This one is also a full adder. Here again one full adder, and here we use the half adder. Okay, this is a first type. Here when the question is asked in the examination, there is no mention that you have to use all full adder or the full adder and the half adder. The question is like this: define a binary adder. Define a binary adder. Explain the working of 4-bit binary adder with the help of a block diagram or a logical diagram or a suitable diagram. Okay, so here this is a block diagram, or we can say it is a suitable diagram for the construction of the binary adder. That binary adder is the 4-bit binary adder. Okay, so here this is a first type. In this type we use the three number of full adder, and we use one half adder. So here the three full adders are there. The full adder number 1, here we can say it is 4 number, it is 3 number, it is 2 number, and this one is the first number. Okay, first one is for the half adder, second, third and fourth are the full adders. Okay, now here these all circuits are the blocks, so or we can say here these are the symbols we use for the full adder and the half adder. Here this is we also called as a block diagram, or this is we also called as a logical diagram. When the question is asked, the answer is similar, and only these diagrams we use for the construction of the binary adder, that is the 4-bit binary adder. But someone having a question that if we have to construct the 8-bit full adder or more than 4-bit, then what we do? Here nothing to do, just we have to add one full adder for one more column. If we have the 5 binary bits, then you have to use the 5 number of the full adder for one full adder for the one column addition, or you can use the 4 number of the full adder and one half adder. It means if we have to increase the number of binary bits in that numbers, then you have to increase the number of the full adders. Okay, so here this is a block diagram, this is a logical diagram, we can say, for the 4-bit binary adder. It is for the 4-bit binary adder. We have to perform the addition of the two numbers. Which are those numbers? The numbers are A number and the B number. A numbers are A3, A2, A1 and A0 binary bits, and the B number having the binary bits, these are B3, then B2, then B1 and the B0. Okay, so we apply these binary bits and we produce the output here, and we see how we get the output where we have to make the connections. Okay, so here we have the A number. Here I am going to apply the A number bit, and it is the A3 MSB. So along with the A3 we have to add the next one, and that is the B3. Okay, so here it is the B3. Then here it is A2 and this one is the B2. Then here it is A1 and this is the B1. Here for this half adder LS bit column, we have the binary bits. These are A0 and here this one is the B0, which we had seen in our previous page. Here the two numbers we have, the first number is the A number A3, A2, A1 and A0. Second number is B3, B2, B1 and the B0. Okay, so here these inputs we applied. As we know, the half adder performs the addition of two binary bits. Here these two binary bits are A0 and B0. It produces the output as sum S0 and the carry C1. I am using, instead of C0, the carry is C1 because I like to maintain it same for the next circuit also. Okay, so here the half adder performs the addition of the LS bit column and the LS bit column bits are A0 and B0. It produces the output. That output is the sum S0. Then the carry generated, that carry is applied as a third binary bit to the next full adder. Means here the full adder we are using, that full adder performs the addition of three binary bits. Which are those bits? The three binary bits are A1, then B1 and the carry generated at the previous column addition. We apply the carry generated at the previous column addition to the next column. So therefore here the carry output of this half adder is applied input to the next full adder as a third binary bits. This full adder performs the addition of the binary bits A1, B1 and C1, produces the sum output S1 and the carry C2. Okay, the carry generated at this first full adder is applied as a third binary bit to the next full adder. So the next full adder, this one full adder performs the addition of the three binary bits. Which are those bits? A2, B2 and the C2. It produces the output and that output is the sum output and sum output is here the S2. The sum output is the S2 and here it generates the carry. That carry is C3, which is added to the next full adder as a third binary bit. Okay, now this third binary bit is added along with A3, B3. So this full adder performs the addition of the MS bit column and it produces the output sum S3 and the carry generated, that carry is now the C4. Here we get the output, that output is the C4, S3, S2, S1 and the S0. If we have to construct the binary adder for more than the 4 binary bit numbers, more than 4 binary bits, then here we have to use one full adder here, and instead of taking this C4 outside in the result, we add as a third bit to the next full adder. Okay, now for an example, suppose here we are using the binary adder and input to the binary adder are here 1, A3 is 1, B3 is 1, A2 is 1, B2 is 1, A1 is 1, B1 is 1, A0 is 1 and B0 is also 1. Then we see the result. Okay, so here this half adder performs the addition and produces the output as a sum and the carry, it having the input as 1 1, input as 1 1. So therefore sum is equals to 0 and the carry generated, that carry is equals to 1. The carry is added to the next full adder as a third bit. So this next full adder produces the output as the sum and the carry. Now the three binary bits are 1, 1, 1. So therefore we get sum is equals to 1 as well as the carry is also equals to 1. Now this third full adder performs the addition of A2, B2 and C2. Then all those bits are 1, 1. So therefore once again it produces the output as sum is equals to 1 and the carry is also equals to 1. When the carry generated, it is added to the next full adder. So the next full adder performs the addition of three binary bits A3, B3 and C3. Now all those binary bits are 1, 1. So therefore it produces the output sum as 3 is equals to 1 and the carry generated, that carry is equals to 1. So here we get the result as 1, 1, 1 and 0. If we perform the addition of the two numbers, these are 1, 1, 1, 1 and the second number is also 1, 1, 1, 1. Here we get the result as 1, 1, 1, 1 and here it is equals to 0. Okay, so this is a binary adder, 4-bit binary adder by using one half adder and three numbers of the full adder. Okay, now we have to say the other circuit, but that circuit having only one change, and that change is instead of using the half adder we use all full adders. Okay, so this is a logical circuit having the all full adder which performs the addition of the two 4-bit numbers. So that's why this circuit is we call as the 4-bit binary adder. What we call 4-bit binary adder. Okay, now here we use the 4 number of the full adders. Here these full adder perform the addition of the LSB column. So here the inputs are A0 and B0. Here the third input is there and that third input is the C0. Here we maintain C0 is equals to 0. So there is no effect of the C0 in the addition of the two binary bits. These are A0 and the B0. Okay. Now its output is sum S0 and the carry C1. This carry C1 we add to the next full adder third bit. So here this next full adder performs the addition of the three binary bits and these three binary bits are A1, then B1 and the third bit is the C1. It produces the output as sum S1 and generates the carry as C2. This C2 is added to the next full adder and here this full adder performs the addition of the binary bits. These are A2, then B2 and this C2. It produces the output as sum S2 and it generates a carry. That carry is the C3. This C3 is added to the next column and this full adder performs the addition of the MS bit column where the binary bits are A3, B3 and C3. It produces the output as sum S3 and the carry generated is taken outside in along with this sum. Okay, so here the carry generated is the C4. It means in answer we get it is C4, S3, then S2, S1 and S0. Okay, so if we can apply the input as 1111, means the A number is 1111, B number is also 1111, then we get the same result as we seen in the previous circuit. Okay, so this is a 4-bit binary adder. This is we call a 4-bit binary adder which performs the addition of the two 4-bit binary numbers. The first binary number is A3, A2, A1 and A0. Second number is B3, B2, B1 and B0. It produces the output as sum S0, S1, here it is S2, here it is S3 and the carry C4. Okay, for this column it is we call LS bit column. For LS bit column either we use one half adder or we can use the full adder. We use the half adder, then here the hardware is different, so instead of using the half adder we use the full adder also, and if we use the full adder then this third binary bit of the full adder we have to make it is equals to 0, so there is no effect of this third bit in the addition of the LS bit column addition. Okay, so this is all about the 4-bit binary adder.